Okay, let's go ahead and get started. So I'm Ed Seidel. I'm the NCSA director, and I'm very pleased to help kick off today's colloquium. We have a colloquium series. For those of you who aren't regulars here, we have a colloquium series on most Fridays. You should check the schedule, but we work very hard to bring in outstanding speakers from across the country and internationally as well. And I'm really pleased that we're doing this in a way that connects to various activities across the campus. So in the last few years, we've worked really hard to build bridges between NCSA and the rest of the campus, and in particular with the College of Education. And I'm going to introduce Luc Paquette, who is a professor in the College of Education, but also an NCSA faculty member who's got some research activities going on here. And we're really hoping to build and strengthen those over time. And I think today's colloquium, you'll get some ideas on things we could do together. So, Luc.
Thank you. Well, thank you, everyone, for joining us today for this talk. It's my pleasure to introduce Professor Ryan Baker, who I've known for almost 10 years now. He was my postdoc mentor when I was working at Teachers College, Columbia University. Professor Baker right now is in the Graduate School of Education at the University of Pennsylvania. His researches focus on how students use and learn from educational games, intelligent tutors, and other kinds of educational software, drawing on the fields of educational data mining, learning analytics, and human-computer interaction. He develops methods for mining the data that comes out of the interactions between students and educational software. He then uses this information to improve our understanding of how students respond to educational software, but also how those responses influence their learning. Prior to joining the University of Pennsylvania, Dr. Baker was an associate professor in the Department of Human Development at Teachers College, Columbia University. And while at Teachers College, he taught the class Big Data in Education, which was a Mooc that was offered twice, once on Coursera and once on edX, with a total enrollment of more than 50,000 students. And also for those who are interested, there's going to be the third version of Big Data in Education is going to roll out pretty soon, I think in June. Professor Baker has served as founding president of the International Educational Data Mining Society, where he currently serves on the board of directors. He has been co-author on 9 award-winning papers. He serves as co-lead of the Big Data in Education Spoke for the NSF Northeast Big Data. So please help me in welcoming Ryan for his talk.
Thank you, gentlemen, for your introductions. Thank you all for coming. It's great to be back in Champaign-Urbana. This is my first time speaking to NCSA, but I actually visited some folks at NCSA, I think, about 5 years ago. So great to be back. Today I want to talk about our work towards massive replication of scientific findings in massive online open courses. So people have said that Moocs are an amazing opportunity to study learning at scale with millions of learners. I think I read that 20 million people now have taken a Mooc, thousands of courses, billions of interactions. Anant Agarwal at edX says that it's a particle accelerator for learning research. And yet, most of the research on Moocs has a certain sameness to it. People will answer questions like, what predicts completion? There's been a lot of work on this question over the last 3 years. People say, doing well on assignments predicts completion. That's a paper by Everybody et al. Watching videos predicts completion. Everybody and Their Brother, 2013 to 2016. And you get a lot of, author A will say, in my course, because a lot of these papers are published on single courses, even though there's literally thousands of them out there. A lot of authors will say, in my course, posting to the forum more is associated with completing the course. And then you'll get author B in the next paper next year, in my course, posting to the forum more is not associated with completing the course. Therefore, author A is wrong. And then you'll get the next year, well, in my course, posting to the forum more is in fact associated with completing the course. Therefore, author A is vindicated and author B is clearly a complete bozo. I think we can do better than this. This is kind of painful, right? Like thousands of Moocs out there and people are arguing back and forth about single courses. Meta-analysis. Very well-known set of methods for integrating across published scientific results. Used to determine whether a claim is true across evidence from many studies. So people can so maybe we should let's just wait 5 years. We'll wait, all these people publish all their papers. There'll be, 60 papers on an individual Moocs. We'll take them, we'll take the p-values, we'll integrate into formulas. Hey, we're done, right? We'll be able to say whether this finding holds. But I think we can do better than that too. We don't need to wait for the findings to be published on 60 different papers. Meta-analyses by nature are focused on fairly general and high-level questions. We can narrow down more. And for any given data set, they're usually limited to what's already been analyzed. Why do we need to limit ourselves to what people thought was interesting? All the data's out there. So in this talk, I'm going to discuss an engine that my colleagues and I are developing with 3 eventual goals. Okay. So I'm determining which findings hold across Moocs. So what findings are true of Moocs in general. Determining which findings hold for which types of courses. So maybe some findings hold for courses mostly targeted towards undergraduates, but not for courses targeted towards people in graduate school or above. Maybe some findings apply to general purpose Moocs, general interest Moocs, but don't apply to more specialized Moocs. Maybe some findings apply to Moocs in the humanities, but not to Moocs in the social sciences. We can answer all these questions, and we can also try to determine which findings hold for which types of students. So for example, maybe findings hold for students who have lived in the United States their whole lives, but they don't hold for students in developing countries. There's a lot of people arguing now that people in Western, educated, industrialized, rich democracies, the so-called weird countries, look very different than students in other countries. That's actually been a problem for research, by the way, because there's a problem akin to the file drawer problem for students in for research in developing countries, which is that if you publish a paper on, say, 100 learners at a top Western university, like Illinois or Penn, the paper will get in. But if you submit that exact same paper and it's on students at the Ateneo de Manila, you'll get reviews back that say, well, would this finding hold in a setting that was more normal and not your setting? I mean, I've seen that review, because I publish a lot with that university. I've seen that review 3 times now, I think. But we can start to look at what findings hold in which settings. What findings hold for students who are fluent in English versus students who are not fluent in English. Especially as we see findings on the linguistic nature of student posting, that might become really relevant. Linguistic background and so on. And most importantly, our goal is to be able to do this quickly. We don't want to have to wait 5 years for a bunch of papers to get out, and then we finally can do a meta-analysis that's more conclusive. So our goal is the power of meta-analysis, power of broad-scale analysis that we can say really holds across a large body of contexts without having to depend on other people doing the analysis first, or more rapidly scalable meta-analysis. The framework I'll be talking about, MORPH, the Mooc replication framework, is a production rule engine built in Jest. If you're not familiar with production rules or Jest, don't worry about it. I'll kind of talk about these in a minute. The vanishing in some ways of production rule systems from computer science research to a large degree in other areas is something I kind of see with a little bit of sadness, because I think they're a very rich framework that allows a lot of interpretability. They were very prominent in cognitive science in the 90s. I think they still have some place. And this is similar to frameworks previously used for modeling learner cognition. You can see that I did not do a good second pass on my slides when I was writing these, and I apologize. But I could talk about John Anderson's ACT-R framework or Alan Newell's SOAR framework. We take findings, published or unpublished, and we turn them into if-then statements. So for example, our template is if a participant who is attribute does action, then outcome. So an example of this would be if a student posts more frequently to discussion forums than the average student, then they are more likely to complete the Mooc. Simple question. And then we validate a rule in this engine by comparing the proportion of cases where the rule is fulfilled to the proportion of cases where the rule's then clause is fulfilled, but not its if clause. So in other words, if we think that completing a course is associated with posting more on the discussion forums, what happens if you don't post on the discussion forums? How often is the rule still fulfilled? So for example, for this rule, we're going to compare posts more frequently and completes to does not post more frequently, but still completes. Our method chi-square test. We're not being particularly fancy here. We could use infinitely complex frameworks. This is a fairly simple framework, especially when you've got this much data. As you'll see in a minute, statistical significance is not really our main question here in some ways. And we're going to use a Benjaminian-Hochberg post hoc correction to deal with the fact that we're testing multiple findings at once. Anyone here familiar with Benjaminian-Hochberg? 2 hands and people I've worked with before. Anyone familiar with Bonferroni? A few more hands. So Bonferroni was kind of the state of the art for post hoc correction in the 30s, like the 50s. Bonferroni wrote about it, I think, in the 30s, kind of in informal terms, but the real formalization of it came in the 50s. It's an old method, and what it does is it tries to say, given all of the statistical tests I've run, can I trust each of them individually? Benjaminian-Hochberg's from the 90s, and it tries to do a subtly different problem, which is, given all the statistical tests I've run, can I guarantee that my overall false discovery rate will be 5%? So whereas Bonferroni is much more stringent than the original definition of statistical significance, Benjaminian-Hochberg restores back that same level of stringency. I want to accept 5% junk. Turns out that we don't really need that. We could use Bonferroni just as well in this because, as you'll see, we're going to get these colossally low p-values because we have such big samples. But this is relevant because we should be using, I think, good methods. The U.S. Department of Education, incidentally, in their What Works Clearinghouse Guide, has switched from recommending Bonferroni to Benjaminian-Hochberg. I think that's a bellwether for this method. Sorry for rambling for 30 seconds, but I feel strongly about this. So we've, at this point, obtained data from 17 Moocs conducted at the University of Edinburgh on Coursera. We actually have 29 instances of their runs. Not a huge set yet. We're in the process of obtaining, I should actually say, we have obtained the data from, and we are currently ingesting into our framework, the data from 56 Moocs conducted at Penn on both Coursera and edX. Our first published proof of concept on our framework, I won't talk about in detail today. It was conducted on a single instance of a single Mooc. Actually, my Mooc that Luke was so kind as to talk about, Big Day in Education. But that's kind of a weird Mooc. So our second use of this framework was to take the data from Edinburgh. Edinburgh is one of the larger Mooc providers. We had a range of courses. You can see them up here. Can folks read this in the back? Cool. So everything from AI to animal behavior to astrobiology to veterinary and equine nutrition to general elections. So a broad range of topics. We had 500,000 students, 86 million transactions. I'm at NCSA, so you're probably all going, wow, what a tiny data set. Why would anyone ever want to work with a data set this small? But I think, and Nigel, Luke, correct me if I'm wrong, I think this, when we published this summer, because it just got into educational data mining as a poster, I think that this may be the largest data set ever published at EDM. So we're still growing. Educational data sets are big. They're a lot bigger than they used to be in education, but they're still not. There have been educational papers published on bigger data sets than 500,000 people, but I don't think they've quite had the wealth of data on each person to have 86 million rows. I think this might be the biggest data set in the history of ed research. I could be wrong. If someone knows I'm wrong, tell me, because I actually want to know. I want to brag accurately, right? So we initially took 15 findings obtained from 5 previously published papers using Mooc data. We're picking these not because they're necessarily the biggest problems ever in the history of humankind, but because these are relevant, right? These are things people actually publish papers on. Somebody thought these were important. They consisted, because we're just getting started here, of low-hanging fruit findings that could be easily replicated. They represent a limited span of behavior. There's much more we can do in the near future. There's richer work out there. But again, we wanted to start with stuff that was low-hanging fruit to demonstrate the feasibility of this large replication framework. Why does replication matter? Because aside from the things talked about before, we do have this crisis of replication. We would like to be able to take the exciting findings people are publishing, these ones and more exciting ones, and be able to find out whether they're really true. So we're just at the beginning. Some examples. Work by DeBoer and colleagues at Purdue. If participants spend more time on forums than the average, they're more likely to complete. If they spend more time on the assignments than the average, they're more likely to complete. Work by Yang et al. At Carnegie Mellon. Do they post? Do they write longer posts? Do they post more? Do they respond more to other people's posts? Do they start threads? Do they start threads more frequently than average? Ramesh et al. I think was also Carnegie Mellon. Do people respond to them? And do they have more respondents than average? So this is mostly having to do with discussion forums to start. Not that that's the only thing that's important in Moocs, but it's a decent place to start because it's a general feature that shows up in a lot of cases. 6 findings from Scott Crossley and his colleagues at Georgia State having to do with the linguistic properties of participation on forums. Does the participant use more concrete words than average? Do they use more bigrams and trigrams than average? Do they use less meaningful words than average the more likely to complete? I'll talk about that one in a minute. So you might think that meaningful words are good. Crossley found the opposite, and we'll talk about what meaningful words mean when we actually get to discussing this result in context. Do they use more sophisticated words than average? And do they use a wider variety of words than average? And we plugged in with our framework Crossley's Tails tool. We did an integration between the code bases in order to be able to run his tool automatically. Turns out that that's been one of the bottlenecks for us in applying to more data because Tails is a relatively complex engine and it takes a while to run. Results in brief, and I'm going to go into detail in a minute. 12 of these 15 published findings replicate after a post hoc correction. 2 of them replicate in the opposite direction of the original paper. But again, across these 19 Moocs, 26 instances. One of them turned out null. So let's look. So if you spend more time on the forums, you're more likely to complete. 29-0. That's pretty conclusive, right? Maybe we'll find out when we get the Penn Moocs in that we go the other way, but I'm not really expecting that because the Edinburgh Moocs, first of all, represent people from all around the world, and they represent a wide range of topics and of levels of expertise. But we'll find out. More time assignments, longer posts, posting more frequently, responding more, starting threads, all associated with completion. Longer posts than average was a more mixed one. You can see 15 cases where it came out true, 1 case where it came out false, and 13 cases where it was a null. All these are wildly significant, but I actually think this one will be one of the places we want to look going forward when we start to figure out what are the features of different Moocs that are associated with these rules holding or not. There's probably different ways these instructors use these forums, or there may be different content. This is something with 19 courses and 29 iterations I don't feel ready to investigate yet, but once we have all the Penn data ingested and we start having like over 80, then we'll really start to be able to figure out what the differences between Moocs are that are associated with these. Starting threads more frequently than average. Students who did this were actually less likely to complete. 27-0 to 2. So I'll talk more about that in a minute. So this is a finding. Yeah, I see one raised eyebrow. We've done some affect work together, so I've learned to read those. Surprise, I think. So we'll talk about that more. But yeah, students who start a lot of threads are not actually more likely to complete, even though if they spend more time on the forums or they post more frequently, they are. We'll talk about what some of these threads might consist of in a few minutes. If people respond to you, you're more likely to complete. And if more response than average respond to you, you're more likely to complete. You can see, by the way, that with the exception of longer posts than average, most of these are dominating, right? But however, that if people were to like run a single study, they might not have found that. You might have gotten a null effect if you ran on one of these 4. If you use more concrete words, Oh, there's a null effect. Sorry, I was about to say something wrong. I somehow messed up my coloring scheme. If you use more concrete words, it doesn't look like you're more likely to complete. There's 3 in favor, 5 against. The rest are all null effects. If you use less meaningful words, still more likely to complete. If you use more sophisticated words, more likely to complete. If you use a wider variety of words, you're actually less likely to complete. 13-2 to 14. Talk about these in a minute. Oh, and I wasn't talking about the odds ratios, but let me go back and talk about the odds ratios for a second. If you spend more time on assignments, you're 121 times more likely to complete the course. Shaking your head no?
The one interpretation.
Oh, please correct me. I probably misspoke.
It's not times
Sorry, yeah, you're right. I just misspoke. That happens. No, thank you for correcting me. I appreciate that. You're right. The odds are 121 times more likely.
You have to drop the more likely. You have two odds ratio. One odds ratio is 12 times the other.
Yes.
Yes.
Thank you. I apologize. I'm saying something unclearly. My brain is not quite correct getting it right, so I appreciate you correcting me. Yeah, thank you. I will. If you don't mind sending me a quick note, I'd appreciate it, because I'm not used to speaking about odds ratios, and I'm saying it wrong, and I'm not sure exactly why I'm saying it wrongly, so if you can send me a citation, that'd be really helpful. Thank you. Not a citation, probably actually an intro stats text. Yeah, thank you. Still, that's a really big odds ratio. 121 is a really big odds ratio. By comparison, a lot of the other ones, so this one is also statistically significant, but 1.24 is not a particularly huge odds ratio. So the effect size is not nearly as big there. Yes, sir?
A really stupid question here, I'm sure, but I mean, if you drop the course early, you're going to do less assignments. So it seems like a completely... Sorry. I'm just worried that I'm not understanding correctly. More time on assignments. I mean, since we're looking at completion, if you drop after the first couple of weeks, you won't spend any time on assignments. So it seems like a completely trivial result, or is it more profound than I'm understanding?
No, I think you're right. These are not particularly deep results. We were starting out with stuff that was really easy to replicate. Because, I mean, it is a published finding. You could argue whether the first paper on it should have been published at all. But you're right. That's probably why it's 29 to 0 to 0 compared to some of the other ones. You could say average time on assignments you actually do, but you'll notice that's the only one that has to do with assignments. Most others have to do with discussion forums, because we actually came across a lot of papers when we were doing our review that actually said grades on the assignments. That's really trivial, right? This one's not as immediately trivial, because you could imagine that you might have had some people going through the assignments really quickly and having but doing all of them and having a relatively low time, whereas some people might have spent a ton of time on one assignment, spun their wheels, and then given up. So it didn't seem immediately impossible, but I agree with you. That's a fairly trivial one. Yeah. At some level, our goal here is not to make and I hope this is clear, is not to make a profound statement about the nature of Moocs in this stage of the work, but to demonstrate the feasibility of creating this replication framework, which can be used for relatively more and less trivial questions. So, for example, the linguistic features coming out of Crossley's work on this slide are a little less immediately obvious, some of them. I mean, using more bigrams and trigrams just means that they're talking about more different things to some degree. But it is interesting that using a wider variety of words didn't show up that way, and we'll talk about that in a minute. Yes, ma'am.
I know I can go back to the paper and find out the details, but do you know off the top of your head how concreteness and diversity were defined? Sophistication, for that matter?
Yeah, so I might actually, let me just see here. Pull that 1 second here. I think I got it. Thank you, though. So these are all from Crossley's Tools for Linguistic Sophistication, tales. I believe that words that are more concrete, that's actually, I think, a relatively standard linguistic variable, and having to do with, for example, a concrete noun would involve a physical object, whereas an abstract noun would involve things like truth or justice, things you can't kind of touch. Meaningful words are words that, this is a little bit non-intuitive, but meaningful words are words that semantically connect to the maximum number of other words. So in like WordNet or a linguist or a map of the relationships of all words to each other, a graph representation, meaningful words connect to lots of words. Non-meaningful words connect to relatively few. I believe that sophistication. Let's see if I have a slide on this in a second. I don't think I do. Sophistication I'd have to look that one up. I think it has to do with relative rarity and reading level, but I don't remember the exact definition of that one. And wider variety is just how many different words they use. Yes, ma'am.
I have I think, a very trivial question. It's like, how you actually define completion of a course here?
So that's a great question. Completion was defined by whatever the university and instructor defined it as. Typically in a Mooc, those definitions vary somewhat, but they typically involve doing a set of assignments. Sometimes you get to drop some, sometimes you don't, and getting an average grade above a certain amount. But these could vary to some degree. And actually, I consider that part of the, I actually want to use the instructor's definition because I don't want to second guess what, the assignments might, for example, be graded. They're typically auto-graded or peer-graded, but they might be graded in different fashion by different instructors to different levels of stringency. So using the instructor's own definition is usually the plausible thing to do.
Thank you.
You're welcome. For example, in my Mooc, we actually say that you have to complete at least 6 of 8 assignments with an average grade of 70 or more. Not a particularly high bar. And usually people who complete Moocs are the ones who kind of stick to it rather than the ones who show great brilliance. Yes, ma'am. Yes, ma'am.
I think it's also interesting to take a look at the goals, the learning goals, because not everyone intends to earn a certificate, for instance, which would be the bar set by the instructor to define completeness.
I couldn't agree more. For this analysis, we're not looking at that at the moment, but other work out of my lab, specifically work by a recent graduate, L. Wong, has found that in that work she actually tried to measure people's intention to complete. Because everyone who's worked with Moocs knows that some people come in to watch one video.
Right.
Some people come in to get a brief introduction to the first week. L actually asked people that. It turns out that people don't have a very good idea of whether they themselves want to complete. Mm-hmm. Because not only do a lot of people say they want to complete and not complete, but a lot of people say they don't want to complete and still do. In fact, if you give people questionnaires on goal orientation and on GRIT, Angela Duckworth's measure of persistence in tasks, both of those are better predictors of completion than whether the student themselves said they wanted to complete. So that makes it a real challenge to actually study that question you're talking about, because students themselves either don't know or can't or don't want to report what their actual intentions are.
I agree, yeah.
Yeah, really big problem. Ella's done other work actually where she's looked at whether people go on to publish scientific papers in the field of the Mooc. That's appearing this summer, I think, at a conference. I think. Can't remember. It's appearing somewhere in the near future. And she found that actually whether or not you complete the course is the best predictor of whether you'll publish a scientific paper in the field afterwards. Mm-hmm. But still, many people publish scientific papers without ever completing. In fact, one core example for my Mooc is a student who actually watched one video and published a paper. So yeah, completion is not the be-all and end-all. Why did we start there? Because it's the place where there's been the most research, and we and that's kind of good places to start for a replication framework. By the way, I have a commercial later, but I'll go ahead and actually give it away a little early. If you've got something you'd like to do with our data, come talk to me. Shoot me an email, because we welcome people submitting either production rules or code to us. We'll run it for you, and you can publish it. Like, we want to share this framework. We want to share this data. And one of the reasons why this is a neat opportunity is because we can't just give you the data. Like, these universities don't actually allow you just to give the data. Part of the reason why we're doing this on Edinburgh data as well as Penn is because actually I'm faculty at Edinburgh as well as Penn. And so I was able to get access through that connection. We can't give you the data, but you can run your analysis on our data through our framework. So some reverses from the original findings. Before, students who start... Did I say this right? Let me make sure I said it right. It's the problem with giving a talk for the first time at a place, right? When you give a talk for the 4th time, everything's polished. So I just want to make sure I said the right thing here. So I have, how many discussion?
Were you
Thank you for your patience in me who's stumbling a little. So, all right, I'm going to trust my slide. I'm going to trust my slide over my brain. Before students who start fewer discussion threads more likely to complete, that seemed wrong, right? I think Nigel actually raised his eyebrows at that. And in fact, we found that wasn't true. It went the other way. Newer findings a little more in line with what's typically seen, what we typically intuitively think. It's worth trying to figure out what characterizes courses where starting threads is valuable. Even though it didn't show up a single time in our set, it showed up in an earlier paper. So there's something special about that course. It would be worth seeing if I don't know if we can actually ingest that one, but as we go forward, trying to figure out what it is that leads to this. It may have to do with content, which we didn't analyze here. Perhaps some courses have more junk threads. And that kind of connects to our next one, which is before, students who used a wider variety of words on a discussion forum were more likely to complete. We found in 13 to 2 cases that students who use a smaller variety of discussion forums are more likely to complete. And that might be because students who use a lot of different words are not focusing on words of specific importance for their current courses, but instead are rambling on a range of other often unrelated topics. There's a couple papers on this. For example, Comer et al. Talked about students who spend inordinate amounts of time talking about what clothes their instructors wear, or engaging in various other discussions that seem of peripheral importance. And if you spend a lot of time on the discussion forums talking about your opinion of the instructor's clothes, you're probably not spending that time thinking about the topic. Incidentally, if you want to ever get ripped apart if you ever want to get thousands of people coming together to criticize you and to learn what they have to say, teach a Mooc. It's fantastic. I never would have known that my bright orange shirt looked like I came straight from the prison to teach the class. So future work, more findings. I talked about 15 here. You had a very legitimate point about whether the second one was actually all that useful. I think we could criticize a lot of these. We're going to look at more findings. There's a lot of literature out there to mine for this. We're going to look at more courses. We're already bringing them in. We're going to look at result twiddling to look at near variance of rules. For example, if a finding comes up true in some courses that students who start threads more than the average do well, maybe it'll turn out that in some of those courses where it didn't hold true, if you just looked at students who were in the top tercile, right, or the top quartile, there might be near variance of these rules that actually do come up true. And so if we can find out whether there's some variance on that, that may actually help us to see how general these things truly are. That's, by the way, a thing you can't do with classical meta-analysis because you just have to do what the analyses people do. That becomes a real problem because when you want to meta-analyze, maybe people have characterized their findings slightly differently and you don't know if it's apples and oranges or apples and apples. In this case, we can actually try both variants, see if they merge. In the longer term, and this is what I kind of foreshadowed earlier, we plan to create an architecture that enables us to open up these data sets to other researchers for analysis. And this is in collaboration with Luke here at UIUC. Data is not always totally free. Right now, it's not just feasible to make all data sets completely open and available to anyone. People have talked in the edX world about the research data exchange and the idea that any university in the exchange could get anybody else's data. Last I talked to people, no one has actually been able to do that. There turn out to be a lot of hurdles still for the agreements in place. So it's hard to share this data, and there's good reasons for that. Because for one thing, a lot of these discussion forum data actually have personally identifying information in them that's very clear. Now, on the one side of it, you might say, if somebody's willing to post to 78,000 people about that they're an accountant from Dubuque, Iowa, and they're taking this course because they want to advance their career, do they really have an expectation of privacy? But, a lot of people can get concerned about that. Especially then when we go into for-credit data, which we plan to work with, or when we go to students who are underage, we have to think about these issues of privacy. It's just not feasible to share all data in education. So instead, we hope to open up our architecture for other researchers to use. I want to underscore, this is kind of how we plan to do it in an official architectural sense, but if there's folks in this room who have a specific finding that they'd like us to test for them, email me and we'll get it in there. We want to do this sooner, not later. We want to do this tomorrow. So the idea will be that first people can kind of directly through a UI submit production rules that can be run in the entire data set with the output of queries then made publicly available. Our idea is to kind of set up an agreement around this that people kind of get embargoed rights on first publication for a certain time window of their analyses before other people can publish on it. And that'll include us. I don't want people to submit stuff to us so we can scoop them. I want people to submit stuff to us so they can write papers on it, and then after they've gotten their first crack, then we can include it in our framework and study it more broadly. And later on, to plug in tools or analysis code that can be run across Moocs. So we've already integrated Crossley's Tails linguistic tools. We're open to integrating other stuff. Obviously, when you start to integrate stuff, you've got to think about security issues. You've got to think about resource usage. We haven't completely ironed that stuff out. We're actually looking to seek grant funding to do some of that stuff. But the big idea is to enable researchers around the world to conduct analyses on huge Mooc datasets without having to negotiate access to data, which is still largely very difficult. This data negotiation step is a big reason why we have so many papers on 1 Mooc or 3 Moocs. Questions up to this point? Okay. So let me just give a quick commercial for some other work in our lab that you may be interested in. So I mentioned this work earlier in response to your question. Studying the links between behaviors in Moocs and long-term student participation in scientific community of practice. We've looked at what people publish. We're actually in the process of looking at LinkedIn data and how participation in Moocs affects students' actual jobs. There's also a great group from Delft in the Netherlands that's looked at how what students learn in programming Moocs actually shows up in their GitHub code. I think that's really cool work they've done. Studying student negativity in discussion forums. We've done a little work to try to systematically study which students it is who are negative. That turned out to be kind of difficult. We did it in a single Mooc, and there just weren't enough people who were continually abusive to the instructor to be able to really get a good vibe on that. But we're actually working with Srečko Joksimovic from Edinburgh to build a model that can automatically detect student flaming of instructors so that we can analyze this across all our Moocs. I'm really interested in figuring out what is that motivates somebody to spend hours sending vile message after vile message to someone trying to give them a free educational resource. Grit and participation in Moocs and comparison and intention to complete, also related to your question. Building adaptivity into Moocs. Big data education will not really have adaptivity in this round, but we're embedding it in an intelligent tutoring systems framework so that in the next run next year, we'll actually start to have adaptive learning, where when a student makes a mistake on an assignment, it actually takes them back to the point in the video that they probably missed or need to rewatch. We can all use a refresher on basic knowledge, as I demonstrated earlier today. Comparing behaviors associated with success in for-credit online learning. So we plan to actually ingest for-credit data into our system. We've already done some work with the Next Thought platform, which is the state platform for higher ed in Oklahoma. And we've studied how students taking the exact same course, either for credit or on a Mooc basis, behave differently. We found that the behaviors are actually remarkably similar. In fact, the same, even though there's different standards for completion, which one of my colleagues in the back asked about, even though the for credit and Mooc have different standards for completion, the same behavioral predictive model early in the course will predict, built on one set, will predict the other set. So that's kind of a hope for those of you who say, why do we actually want to study Moocs at all? Why not study for credit? Even if you think that that's the for credit's the only place that matters, the findings of Moocs seem to have a lot to hold to bear. That said, though, what's associated with short-term completion is not always what's associated with long-term completion. Even though there's clearly replicable work showing that posting more to discussion forums is associated with completing courses, both in Moocs and in for credit, posting more to discussion forums is not associated with publishing a scientific paper afterwards. People who publish scientific papers are just as likely to be lurkers during the course itself. I hit the wrong keyboard. And finally, just to say other work you may be interested in, follow up with me afterwards. Modeling complex skill and inquiry skill in online simulations. Automatically detecting students' emotions and disengagements in online learning, like on simulations and homework platforms. We don't do that as much in Moocs, but there's been a lot of work in sentiment analysis in Moocs that we're planning to build into our framework in the future. Detecting Eureka moments during online learning, so figuring out when a student goes from not knowing it to knowing it in their learning process. Modeling which features of the design of math problems impact a student's affect and engagement. Large-scale field observation of student engagement. We have an Android app for conducting work both in online and offline platforms that's now been used by over 150 researchers in 4 countries. Why did I say 12? 150 researchers in 4 countries. If you're interested in using it here, we'd be happy to get it built up here. And student engagement and behavior in online learning across different cultures. We've replicated some of the same online learning studies in the United States, the Philippines, Brazil, Mexico, Belgium, and Portugal. And we are looking to do some of the same thing in our Mooc research. So thank you very much. All the papers I've talked about are available free on our webpage. Our next iteration of our Mooc starts June 19. Thanks for the plug earlier, Luke. And all our new publications show up on our Twitter and Facebook feeds, which are otherwise low traffic. Thank you very much for your attention. I'm glad to answer any other questions.
Thank you, Ryan. We have time, about 17 minutes for questions.
I ended early, I'm sorry.
So it looks like, my name is Maxim Belkin. So it looks like you made an implicit connection between completing the course and success. Is that true?
Well, so let me answer that in 2 ways, because I think you've hit on an important point here. First of all, I would say that if we are making that assumption, we're making the same assumption that most of the field has made, because there's been around 200 or so papers on studying Mooc completion, and I know of 3 papers on studying other long-term impacts, 4 if you count Coursera's white paper. So most of the field would actually agree with this, folks. But second of all, I think that actually completing Moocs is associated with long-term outcomes, although, as I mentioned in response to an earlier question, it's not the only thing. You can just watch one video and then publish a scientific paper. But in fact, the best single predictor of whether you will publish a scientific paper in our research is whether you complete it or not. So it's certainly not the only thing, and it's certainly not perfect, but it is at least some indicator of somebody who is invested in the topic.
Okay, thank you. And the second question, so who will use the results of your research? Will it be Mooc developers? Will it be users?
So I think that this work has both basic research implications and applied ones. I do agree with Anant Agarwal that Moocs are a great place to provide basic understanding of phenomena surrounding learning and surrounding engagement. Figuring out which behaviors in which context for which students are associated with completion or getting a good grade if it's 4 credits, I think is a question of general interest. But I think that in terms of the audience that I would think beyond the basic research that would find this useful, there are a lot of people out there who are building models that can infer whether a student is at risk of dropping or stopping out and can interact with them. That's become quite a big business in the 4 credit space. To the extent that Moocs and 4 credit are blending together, I think that this can be relevant kind of as that blending is occurring. But if we can figure out what are the behaviors associated with successful completion, we can A, identify students not engaging in it and talk to them, but B, we can also figure out what's going on in the design of specific Moocs that encourage or discourage those behaviors. For example, if you have a Mooc where students who do participate tend to complete, but there's very low discussion forum participation, figuring out why a course has lower discussion forum participation than other courses, say, of the same type, can be useful.
Okay, thank you. So it looks like you implicitly answered that it will be useful for Mooc developers.
Yeah, that would be my answer.
Okay, thank you.
You have looked at success, course completion as outcomes, but what other interesting outcomes have you thought of or have you worked on? I know course completion is very common. It's common for many people writing papers. It's very easy to publish a paper.
So the trick is that most of the indicators that are better are hard to get at scale, right? And as I mentioned, our lab has looked at who publishes a scientific paper in the field, but that's a time-intensive process, which again involved insider access. I had to look at who actually had submitted papers. That's something that's not necessarily easily publicly available. You can look at who publishes. That's a smaller set. That takes a while, right? That's a longer-term outcome. LinkedIn is the sort of thing where you can develop a crawler and you can look at LinkedIn to look at how it changes jobs. You can also give post-tests of learning, which some folks at MIT have done. So that's another indicator of success. In general, I think that completion, it's the lamppost problem, right? Why are you looking for your keys over by lamppost? Is it because you dropped them there? No, it's because that's where the light is. That's an easy one to study, and other ones like learning gains and participation in the scientific community of practice and changes to GitHub code like the Delphi people have studied, job change, those are all harder ones to study. That doesn't mean they're not important though, and I hope I've given some impression in my lab that we are looking at those problems as well, just not for the full span of this data. And just let me say one more thing. Let's say you want to look at publication and a scientific submission to scientific publications as one of your indicators, right? We couldn't do that for all the Moocs there. And even for the ones we did it for, we would have to figure out what the relevant Moocs are, the relevant publication venues are for each of those, and get access.
Sure. Thank you.
Can you talk a bit more about detecting Eureka moments? Because that sounds really interesting for those of us who want to know, like, when did the light bulb go off? What was the thing? I tried 5 things and one thing seems to work. And I'm just curious if in this very large data set there's enough in there that people actually tell you or you can see it.
I don't actually think we could look at that very easily in our Mooc data because the situations in which we looked at that, and by the way, email me or Google MBMLM. Email me, I'll send you the papers. We call this the moment-by-moment learning model, and we've developed it in the context of intelligent tutoring systems, where every item students do is clearly tagged with skills, and there's an underlying good skill model. In those cases, we can actually probabilistically infer, based on student inflections in performance, when a student went from getting things wrong a lot to getting them right a lot. We actually, in that case, we look at individual actions. We look at the probability the student knew it beforehand based on their previous history, using standard knowledge modeling methods, like Bayesian knowledge tracing. And then we look at cases where a student had a low probability of knowing it and then got 2 right in a row afterwards, and use that to seed a model that then looks for those kind of behaviors. We then kind of look at the very highest end of the distribution on that. And we've been able to find, we had a paper in cognitive science last year, where we were able to find, for example, that students who continued to persist on, there's been a lot of literature on the benefits of help seeking, but it turns out that students who kind of bang their head on something several times on a specific problem where they've gotten help in the past, but not now, they're going to bang their heads on until they get it right, those are the students who tend to have that Eureka moment. Another behavior that is relevant is also, after making errors, stopping to think about it. So pause, those key pauses. I think that's really fun stuff. It's hard to do, though, in a Mooc, because typically the content authoring in Moocs is not tagged with skills to the quality that intelligent tutoring systems have.
So very often when people are teaching Moocs, they're thinking about how you reach out beyond your university. But often people increasingly seem to be actually applying it within the university itself. And so rather than having a lecture like this, the professor might just invest in doing the Mooc, and then that's the course, even though it's for locals as well. And so at some places, I know at MIT, I was talking to the physics department chair about the idea that they would teach the class, they would incentivize professors to create Moocs for MIT students, and then they'd give them teaching relief as a sort of reward, because there's a lot of investment to create that. But then often what would happen would be that the professors would actually spend more time with the students in sort of discussion sections and so on that they weren't able to do. So, and that's in a form of teaching relief. So do you see this sort of thing happening, and how effective is it?
In fact, I've done this with my own Mooc. So big data education has been a Mooc, but actually when I teach my equivalent course, and let's face it, it's not quite equivalent. I actually don't think a Mooc can replace a course from a live instructor with a smaller number. But what we do is students watch the videos between classes, and then when we get together in class, we do problem solving together in class. They ask me questions from the videos. We engage in deeper discussion. We do activities. It's a much better experience, and we actually have some data on that. So teaching a course on data mining for students in graduate schools of education is not a trivial undertaking. A lot of the students who come to my classes, both at Teachers College Columbia and Penn, don't have the same kind of mathematical background that people come in a computer science department. The first time I taught this class at Teachers College without the Mooc, I actually had a very high drop rate, students got very intimidated and they dropped. The next time I taught it, I had almost no drop rate, and almost every student got a very high grade. Now, of course, I'm the one assigning the grades, but drop rate is kind of neutral, right? My Mooc has also served as the basis for classes, I know at least at, I think, 3 other universities. So I really agree with that point. I think if you can flip the classroom, have the lecture and the didactic transmission of information happen offline so that you can take that time between student and professor and use it efficiently, so much more powerful educationally.
I was going to ask, I think maybe a similar question, which was about the online courses that we do here, and whether your framework would be such that you could also plug it into data from online courses locally to look at some of the questions that you're looking at there.
Absolutely. We are actually talking to folks at Penn about doing this, but our first priority is to kind of get built up our ingestion of the Moocs and the Mooc findings. That's the second priority, but our colleague Shane Dawson at University of Southern Australia is actually working on being able to import his university's data. One challenge with that is, quite frankly, I know some folks in this room have had to deal with the joys that are Coursera data. Canvas data is worse. Canvas data is significantly worse than Coursera data. Luke has had the pleasure of, I think, I don't think you or I looked at directly, but we supervised grad students jointly who had to work with Canvas data. And it's kind of a nightmare. Moodle data from the plugin can be better, and I think Blackboard data is also better. But yeah, absolutely.
So do you have is the architecture such that you have a plugin to read different data, and do you replicate that data, or do you read it directly from wherever it's held?
We currently have a plugin infrastructure where we translate it from its current format to an intermediate format. There's a format called MoocDB, and we didn't end up using it because it wasn't quite rich enough. We have our own intermediate format, and we can currently ingest edX, old Coursera, and new Coursera. And there's no principled reason why we couldn't ingest any other platform except probably Canvas. We can ingest Canvas, but we're just going to be missing a lot of key stuff because their data is really lousy. Yes, ma'am.
Thank you for the presentation today. Going back to the completion rate, I have a question here. So most MOOCs are designed the same way or mimic the same undergrad courses and graduate courses, which meant for these students who commit their time and effort, and they don't have responsibility, they just wanted to take these courses. So most of the professors do take the same thing and put it like in Coursera to teach it for thousands of learners, the same thing, the same way of participation, only one way of participation, doing lectures, doing forums. And they assume that students are going to complete these courses. But have we thought about the different types of participants who take these MOOCs? Have we ever thought about that there is an experience level that they may vary among these learners? Have we ever thought about that these also participants are full-time employed? So I wonder, did you take these things into consideration? Thank you.
Well, so I think you can answer that question in 2 ways. One is as somebody analyzing the data post-hoc, and the other is as someone designing a MOOC. In analyzing the data post-hoc, you're limited in your ability to make inference about individual people. Because oftentimes, where would you get that information from, right? You have to know, if you want to look it up online, like in something like LinkedIn, you have to actually look them up. If you do a questionnaire, your response rates are abysmal. Response rates to questionnaires in MOOCs are abysmal. They're very poor. And there's a strong selection bias. That's a real limitation because we can't force people in a free thing to fill out a 200-question questionnaire or even a 15. If you make it really short, you get a better response rate, but still, they're very poor compared to what we're used to seeing in compulsory education. In terms of a designer of MOOCs, that comes down to what you want to be doing with your MOOC. When I designed my MOOC, it was designed as an equivalent of a graduate level course. I got a lot of people criticizing me on the forums the first week of the first iteration saying, this is too hard. I need to know algebra. Why do I need to know algebra to do data mining? Yeah, I know you laugh, but and we tried to be clear in our second iteration what we expect, but we still got a lot of people who didn't have those expectations. Other MOOCs are targeted towards a more general audience, like say Al Philrice's Modern Poetry MOOC. at the University of Pennsylvania. That's targeted towards everybody. I think as a designer of a MOOC, you have to decide really clearly who is your target audience, who are you going to cater to. You can't cater to everybody. We can't teach a MOOC on educational data mining that we expect to be of value to people working in company. We designed it for people who are kind of current graduate students or working in companies using data. We can't make that available to somebody who's taking this kind of on a lark. But other MOOCs might want to be thinking more about the demands. Finally, I do want to say I don't actually think most MOOCs are quite characterized like you're saying there, of taking an existing course and translating it online. Because I think inherently in making a MOOC out of it, you cut the heck out of it. When you consider that most MOOCs have somewhere on the order of 5 or 6 hours of video content, and how many hours of speaking content you have in the classes you teach, you're cutting the heck out of it and you're figuring out what's most focused. I certainly don't cover nearly as much in my MOOC as I do in my live classes. And I think that's just an inherency of the medium. One live class full of real University of Illinois or Urbana-Champaign content is gonna translate to multiple MOOCs, in my opinion. Cool. Thank you all, and I'll be here the rest of the day, and please email me. I'd be happy to chat more. I really appreciate all your questions and comments.